Welcome, folks. Welcome, everybody. Very good morning, good afternoon, and good evening, wherever you might be joining us, wherever in the world. So welcome to this webinar. This is Modernization with .NET 6. And we're going to talk about all things web today and, think through your migration, your modernization strategies. So we are delighted to have you here. Thank you. And it's going to be 2 hours of really good content. This is our team today. Let's see if I can find my mouse. Okay, so I'm one of your hosts, Sam Basu, and with me I have my good friends, Ed Charbeneau and Veli Pehlivanov. So do you folks want to introduce yourself?
So I'm Ed Charbeneau. I've been a developer advocate here at Progress for about 6 years, and I've been doing .NET development for 20 years. So I've dealt with all of the flavors of ASP.NET, from web forms all the way up to Blazor.
Nice. How about you, Veli?
Hey everyone, and thank you for having me, Sam. I'm Veli, co-founder and CTO at Resolute Software. I'm a former Progress and Telerik member and have had the pleasure working on some of the Telerik components back in the day. I'm a .NET developer myself too, with a little over 14, close to 15 years of experience in the .NET world. And I began my journey in .NET back in the ASP.NET Ajax days when it was brand new and very cool. Thank you.
Yeah, well said. Right here you have Sam and Ed's social handles if you need to get hold of us. We do also have, some folks in the back rooms with us. So this is your time, you're investing. So please ask away questions. There's a Q&A panel, so you can ask away questions. And then I'll have a slide where you can also ask us questions on Twitter if you're on the social. That way you can leave a breadcrumb trail. And while we are speaking today to you for this webinar, we all know what's going on in the world. So any type of military conflict is undesirable. So hopefully, if you have friends and family, they're safe and you can focus on work. All right. So this is what we have for you in terms of agenda. There's a lot going on, and it's a good thing actually that between Ed, Veli, and me, there is no dearth of people who have seen it. We are all old people here, all three of us. So we have kind of seen the entire journey. .NET hit 20 years this year, and then Visual Studio is about to hit 25 years. So we have kind of seen all of it, but I think when you look at the whole modernization approach, we'll talk about the why first and what are some things you can do. It's not like a big bang approach. It's not like the one thing that you need to do to get everything modernized. It's a slow process, and maybe you take small bites out of things. So I'm going to start off with APIs, and then Veli is going to talk about all things architecture. How do you move your data? What if you have web forms? What if you have MVC? And then Ed's our resident Blazor expert. He's going to come in and talk about all things Razor and Blazor, and lifting and shifting your applications. That's going to be a lot of fun. Like I said, this is our hashtag on Twitter. So if you want to ask away questions, use the hashtag #HeyTelerik. So even if we can't get to it during the webinar, we will have a breadcrumb trail and we'll get back to you. And anything happens during the webinar, we are recording it. So if you're, if you have to run for a meeting, if your internet connection drops, don't worry, we are recording this all in high def, and we'll put it up on our YouTubes as soon as we can. Okay, excuse me. So now, before we start about migration and modernization, I think we got to answer the question: why is it something you should consider now? So if you have been on the .NET journey, we have seen .NET Framework grow and evolve, and then we see .NET Core, .NET 3.1, 5, and now .NET 6. So this is the latest .NET you can use out of out of the box that's production ready. .NET 6 came out in November of last year. Along with it, you have all the tools that are now cross-platform on Windows or on Mac. And it's fair to say that with .NET you can build any types of apps that run on any types of devices, physical or in the cloud. But with .NET 6, you get a little label that's called LTS, which is long-term support label. So it means that enterprises have a little bit more, support and a little bit more confidence going into .NET 6, because you're assured of like 3 or 4 years of support. Not to mean it's going to run out beyond that, but you have guaranteed support and all of your apps will run on .NET 6. So a lot of customers that Ed, Veli, and me talk to, they are thinking about modernization, bringing in some modern bits into their existing web apps. So let's talk about all of that. That's the reason why we are talking about this. So we are here, to enable your success. Maybe there is no right or wrong way. There is no, silver wand. So it's just all about what you want to maintain, what your app needs, what your team needs, and you take small pieces to modernize. You should not be afraid of going into this. You should understand all of your options. What things make sense for your code base and your team, so you understand the frameworks, and some modern UI tools will help. And if you really want some support, Veli and the team, they are really experts at modernizing. So reach out to us. We are happy to help with UI, with our expertise in terms of how you modernize your apps. Okay, now before we start, there is a lot we are going to unpack, right, in terms of everything ASP.NET and all the different flavors, and how do you move your apps forward, how do you move your data forward, how do you move your UI stack. But we wanted to ask you a quick question, and there's going to be a couple of these, to keep things interactive. So we want to know, what exactly do you have in mind when you're thinking of modernization? What are you trying to modernize? Which path are you taking? So are you on ASP.NET Ajax or Web Forms? Are you trying to move to ASP.NET Core, or are you trying to move to Blazor? Are you thinking of MVC to Blazor, or are you thinking MVC to Core, or are you not considering anything at all? Which is also perfectly fine, because .NET Framework is there for a long time. So if you are fine with .NET Framework, then you should be fine. Your house is not on fire. But if you are looking to bundle .NET or use some of the newer APIs with your apps, then you've got to consider some migration and modernization paths. So we really want to get a feel of where all of you are in terms of your modernization journey. So I think we have about 30 seconds to talk through this. So let us know. Going once, going twice, and going thrice. Let's see where all of you are. Oh, look at that. Fairly mixed bag. Ed, this doesn't surprise you, right?
No, it doesn't surprise me at all. Sam.
Yeah. So
looks right where we thought we'd be.
Yeah, so it's a mixed bag, and that's exactly the point. Like no two apps are the same. You have your code bases, you have your data tiers, you have your UI stack, and you're considering, like, should I jump all the way over to the most modern bits, or should I take like baby steps towards it? So good to know, good to know. So what's good here is we're going to try to address all of those migration paths today, and see what's in store for you. All right, first thing, I am not the person you want to speak or hear me speak for too long, because Ed and Veli are really the web experts. I'm an old man. I do native desktop development. I do native mobile dev. But the small piece of ASP.NET that I really find myself excited about are APIs, because I get to use APIs from my desktop or my mobile apps, or heck, I mean, if you're doing any type of modern web apps, you likely have an API stack, right? So this one part of it is what I find really exciting, and there are some good things going on. So the first thing is, with ASP.NET and .NET 6, you're going to have this new thing called minimal APIs, which is a new way of thinking about APIs. If you are from other stacks like Node.js or anything else, you have a much easier way of standing up an API and serving up data. Right, at the end of the day, that's what most of us are doing. We have a tier. Maybe it's a bigger, more heavier tier than just an API. But if you just want some data over a RESTful API endpoint, this is kind of a really easy way to think about it. You don't have to do this. No one's forcing you. You can still do the full web API. But my point is, if you have a web API project today that's running on .NET Framework or .NET Core 3.1 or .NET 5, much of the data that you're pulling is either through like Entity Framework or stored procedures. So that type of code really doesn't have a lot of dependency on Windows or .NET Framework. So consider, if you can, moving things over to .NET 6, because you're going to gain a lot of performance. But if you are starting from scratch, minimal APIs is maybe something you look at. It's just literally 3 lines of code. They have lowered the barrier to entry, so anybody just can come in and start up a new API on .NET, and it's super fast. So it's low ceremony, very easy to get started, and then you can build up from that to make it like a full-on MVC driven API set. And that kind of feeds nicely, and I think Ed is going to talk about this as well. We are not talking about desktop and mobile a whole lot, but I find this to be exciting. This is .NET MAUI, which is the evolution of Xamarin Forms if you're doing native apps. And then the only reason I bring this up is if you are doing Blazor, which is ASP.NET, and Ed's going to talk about all of this, you actually do have a very legitimate way of bringing your web assets, your web code into native desktop and mobile apps. And all of your Blazor components, your routing, all of it starts working from a native standpoint, which is really exciting. And Ed's going to show you more about this. But these are the things that I am into as a native developer, and I find this exciting. So let me show you that real quick, and then we'll switch gears. All right, so first thing is you want to get .NET. To get the latest .NET, I think you can see my screen. So this is the latest .NET 6. You can download that for Windows or Mac or Linux as well. So go get the right bits, and then you're going to see some of these things light up. So in terms of where things are, you can do Visual Studio on Windows. I'm on a Mac here, so I'm going to just show you what version I'm using. So if I do a .NET version. Hold on, I am not in the right place. So let's open up my terminal one more time. Maybe bump up my fonts a little bit so you can all see. Interesting. It is not liking my .NET version, but I have .NET 6, so it's not liking something about my version. But let's do a .NET new. Let's do a list maybe. There you go. So this is a list of all the templates that I have if I'm doing command line. And again, I'm doing this on a Mac. I can do the same thing on Windows in Visual Studio, file, new project. These are all the templates that you see. Now, out of the gate, you see all of these ASP.NET things, right? So what I'm trying to tell you is if you do .NET new web, you get a certain project type, which is the minimal API. And again, you don't have to use it. If you do Web API or Web API with the Razor, that's when you get the full MVC supported Web API project, which has the CRUD, the create, read, update, delete. So you can start there, but it's a little bit more ceremony, or you can start with web, which is really lightweight. So I have a minimal API project that I want to show you really quick. So here's my CLI projects, and I'm going to go into my minimal API project, and I am going to, well, actually I already have it open, so let me show this to you in VS Code. So right out of the gate, you notice how simple this is. It starts with .NET 6 as my target framework. I can, implicit usings. This is a C#10 feature, so I have file scope namespaces. I have implicit usings. I have global usings, so I don't need to have all those like big using statements in every file of my project. It can just be in one place. So it's very simple, clean SDK style project. And what I'm doing here is just bringing in one NuGet package that's called Swashbuckle with ASP.NET Core. Now take a look at my program.cs. I got a bit of code here, which a lot of it is unnecessary. The one thing you do need is the builder. This is the .NET generic, the host builder pattern lets you bring in dependency injections and things like that. But all that you need is the var app builder, and then you need to start up your app. That's just those 3 lines you need. I have a few extra things here. You'll notice that I am, mapping my routes, just the way we do it in, Web API. I have a get, I have a post, I can have a delete, and I can just map things really easily. So my index or my base thing is hello world. So if I go back here and let's clear this up so it goes to the top, I can do a .NET and I can do a run. So that's how simple it is to start up an application. It does the build, and it notices that it's an ASP.NET project, and it says I'm up and running on localhost. So if I go up here to localhost 7197, which is actually configurable based on your settings, I get hello world. So that's my hello world get, which is this line of code. Then I can I can accept parameters. Like I could come down here and I could say hello, and then I could say let's do Veli. So it says, oh, I didn't have the / in here. There you go. Now it says hello Veli, because that's a parameter that I'm passing in from my URL. I could do other things, like for example, I could ask for a person class. If you have a POCO object that's a plain old C# object here, it returns some JSON here, which is actually coming from this line of code here. Person here is a C# record here, or any type of C# object. It will flatten, do the deserialization, and send it back up as JSON. You don't even have to have it defined. Like if I do go to my to-dos, you can define your business objects right in line. It can also do things like post. This one here is a do bad, which essentially means it's going to give me an error because I'm trying to parse an integer as a string. So if I go down here and if I say do bad, you're going to get that unhandled exception. And it's pretty clear to say, hey, you're trying to parse an input string as an integer, so that's bad. Now, what is really good here is with just one line of code here, if my app dev is, if my environment is development, I want to use this thing called Swagger. So Swagger essentially is a nicer UI over something called Open API. So Open API is a standard. It's defined in either JSON or YAML. So anybody without a programming, agnostic way can look at your APIs without understanding what it is, and it's just a really nice way to kind of visualize your API. So I already have that with just one line of code, because I can go to the default here. Let's go back to my browser, and I can go up here, and I can do Swagger right here. So right out of the gate, it does a reflection and tells me these are all the endpoints in my API, and I can do that same get person right here. Try it out. I can do an execute, and you will see the response coming back. It is like Elon Musk right here. So that's how easy it is, to visualize your API with Swagger and support open APIs with minimal API. And that's how simple it is to. Hold on, I'm getting a phone call which buzzes everywhere. So that's how easy it is to start up a minimal API. And once you have this, you can use it from any type of app. You're building a modern web app, so Angular, React, Vue, jQuery, you can call it you can call this from Blazor, you can call this from .NET MAUI or any type of iOS or Android app. And this is what excites me as a native developer, that it's so easy to expose an API from .NET and running on .NET 6. And again, you don't need to do this. If you have an existing web API, please consider moving it over to .NET 6 so you gain the performance benefits. But the API part of it is what I care about as a native developer. So I'm going to stop here because I know Ed and Veli are the folks that you really want to hear from. So let's go back in here and let's do one more poll as we actually get into the meat of things. We heard you what you're trying to migrate, which type of ASP.NET to Blazor, to MVC, to Core. Let's do another quick poll here. All right, so which type of modernization effort do you think you might need some help, right? And this has to do with, a lot of us deal with like legacy code bases. Sometimes we're a little, afraid to touch things because we're not sure if we're going to break things. So there are different aspects of, migration and modernization. Is it the UI or is it the UX thing that, bothers you the most? Is it, the frameworks? Is it, just the core, software dev, which is, cleaning up your code base and getting it ready to move? And Veli's going to talk much more about this on how you can take baby steps so you can slowly set up your code base nicely to move and shift to a new framework. So any of this sounds scary to any of you that you could use some help with? And we're going to try to, spill out most of those details. But again, this is not something to be scared of. There is a lot of resources. We can help. So tell us what you think. And going once, going twice. And let's see your responses real quick. Okay, so combination, 40% of the above, and migration to a new framework. So Veli and Ed, this might be in your ballpark. Moving to new frameworks is not easy. You have to understand what the differences are and what the moving pieces are. So that's actually good to know, and it's a good segue for me to bring on Veli. So Veli, I'm going to do a handover to you so you can share your screen and walk us through some architecture. So what we need to know. All right, you should have presenter rights.
Thank you very much, Sam. And you guys should see my slide deck now.
Yes,
right.
Yes, we do.
Very well. Thank you for walking us through the minimal API concept here. I really liked it. Also for an additional reason, we very often do API prototypes early on as we figure out some design aspects, for example, the front end or the back end, or how the two will work together, particularly if your application doesn't have a previous API and your team is new to API development. This might be a great tool to bridge the gap between front end and back end development, where API development needs to happen very quickly in the beginning, just to establish the basic protocol for communication between the server and the client. Great tool there. Thank you for sharing. All right. So shifting gears here a bit, and we'll talk about web forms to modern .NET. We've been doing web forms a lot in the .NET world. It's a great technology. It enabled desktop and web developers alike to get on the modern, back in the day, version of .NET and start their web development journey, right? But it's 2022 today, so it's maybe time to move on into a new generation of technologies in the .NET world. And luckily, Microsoft has a lot of options, and we'll look at some of those today. So that's me talking. I briefly introduced myself in the beginning, but I've been doing .NET application development since 2008. And I have luckily been able to start modernizing some of those set applications since 2019, where Resolute software was established, and we are a bunch of software consultants and developers who like a good challenge in the .NET world. We specialize in Microsoft, in the Microsoft ecosystem and progress technologies like Telerik and UI. A very brief overview of the ASP.NET timeline. Released back in the early 2000s, ASP.NET 1.0 was very progressive for its day. It was a server page paradigm where you would write a bunch of C# and markup to create server pages. In 2007, Ajax came along and really revolutionized the way we do client-server applications by providing seamless asynchronous callbacks to the server that reduced a lot of flicker and really provided for a much smoother overall user experience. In 2009 and onwards, Microsoft decided to introduce a brand new concept for web application development in the .NET world, and where MVC came out, it was largely praised for its simplicity and really its closeness to the natural way the client-server architecture works in the HTTP world. It did not try to abstract away the complexities or the intricacies of having a client-server communication pattern, but tried to facilitate a lot of those communications by providing language and framework constructs that naturally fit the concept of a front-end markup page that connects to your backend controller or MVC controller in this case. And it was a paradigm shift in a certain way from the typical code behind or page code behind concept in ASP.NET to a more cleanly separated client-server architecture with a razor page and a controller segregated cleanly. In 2016, something interesting happened. Microsoft announced that they are unifying different flavors of .NET, and .NET Core 1.0 came out, and it was announced to be the future of .NET. Well, for good or bad, there was probably only one way web application development would be done in the modern .NET world, and MVC carried along, and web forms was more or less left behind. So we are now talking about modernizing legacy web forms applications, seeing that the modern web is more MVC driven or promotes API and client-side development with different set of paradigms than web forms. I'll continue with one brief disclaimer here. Just because we're talking about web forms modernization does not mean that web forms is dead. It's old, but not obsolete, as the slide says, because the .NET framework in its latest versions, which also includes ASP.NET Web Forms as a framework and component, is itself a component of the Windows operating system, which means that it continues to be supported. And you see here the last 5 or 6 versions of .NET Framework do not even have an end date promoted, because they will continue to be maintained and supported as long as the respective Windows Server and Windows versions are supported. This really means that there's no so much a time pressure for modernizing your web forms applications the way that, for example, Silverlight applications have, now that Silverlight is officially dead. And if you still have Silverlight applications running, well, you are probably catching some of the last trends here, modernizing or getting off of Silverlight. Not the case with web forms. It will continue working for the foreseeable future. Well, still, we see a lot of good reason for businesses to decide to modernize their web forms applications. Generally, we see two types of forces, internal and external, for deciding to modernize a legacy web forms application. Some of the internal forces include the typical characteristics of a legacy technology that pushes development teams to move on and really keep up with the latest and greatest generation of web development tools. It's getting hard to maintain, particularly because of an increasing lack of talent. New generation, new wave web developers really want to work with the latest and greatest, not so much with legacy technologies like web forms. And depending on your application size, architecture, and longevity, you may have piled up a set of performance issues that might be creating some difficulties for your team. Probably even more importantly, sometimes at least for the business, are the external forces that are really about hampering your growth or limiting the added value that your web forms application provides. Particularly, some of the reasons that we see in our modernization projects include, for example, negative client feedback about choppy or non-performant applications that are not updated as quickly or as thoroughly as the modern user demands nowadays. Right, with all those consumer-grade applications that the modern user is, used to having, we also put a lot of pressure on our business applications to look good, to feel snappy, to respond immediately, and to not have the user waiting for data or screen changes. Not very much, characteristics for classical or typical long-term web forms applications. Most of the times we have some problems with the UI. It's maybe not as intuitive as we need it to be in 2022. Maybe it's not responsive enough, coming from a different age and having been optimized for desktop environments, and maybe smaller screen sizes like 17 or even 15-inch. And then overall, we are seeing customers losing competitive advantage the longer they invest in maintaining those legacy applications. So this creates a lot of opportunity for projects that are looking to modernize or to get on a much faster trend here with modern.NET. We see a category of objectives that are driving the modernization projects or the modernization projects that we are taking up nowadays. The typical modernization objective has to do typically with preservation of the main system capabilities, what we call the table stakes. So it is generally considered that unless your new modern system can extend the typical system capabilities of your legacy, it's not adding significant value, or the added value of such a system is maybe limited to, yes, better UI, maybe better performance, but the system capabilities, if they're not growing over time, we're not adding significant value. So we see that the modernization objective typically must preserve and then extend all system capabilities. If you are modernizing a system and you produce an output that has only half the critical system capabilities of the legacy, well, guess what? You are probably not doing an outstanding job in your modernization effort, because half of your users are probably left behind. Another incentive or objective for our modernization effort is that we most of the times need better data pipelines. Data is growing at an ever-increasing rate, and the rate that data was collected and analyzed by modern applications today is much higher than it was some 10 or 15 years ago. Back in the days, those legacy web forms applications were typically created. The expectations are different, the data volumes are as well. So one major objective for modern .NET applications is to minimize waste in storage, processing, and network bandwidth. We need more efficient data pathways and pipelines to be able to sustain a much bigger data throughput. We also see the need for a more decoupled application architecture. And by decoupled, we don't only consider microservice, architectures like the typical hype is today. Regardless of whether you're doing microservice or monolithic applications, we like to look at their n-tier segmentation or the breakdown of a typical system into discrete data layers with segregated responsibilities. Along with this, we very much look at some of the basic solid principles in system design to make sure that your code is as manageable as possible. In addition to that, the modernization projects are typically an opportunity for a major UI overhaul. And as I mentioned, modern users need snappy, adaptive user interfaces that run on a multitude of browsers, different device types. Bring your own device is a trend that helped this or increased the need for modern UI in a major way. So this all creates a pressure towards the typical legacy applications for better UI, more performant, and more engaging for the end user. Last but not least, deployment costs are increasing as the application size increases as well. Maybe the complexity of those components are getting bigger, and this creates deployment costs that are, so to say, less than optimal. So one objective that modernization projects may have is to optimize deployment, right? Faster, more frequent deployments, and more flexible deployment options. And in a few slides, we'll look at the different ways modern .NET and Microsoft's Azure Cloud Services provide in terms of various deployment options. When we talk about modernization patterns, what we like to start with typically are some of the anti-patterns that we see happening over and over again. A lot of times, modernization efforts are mistaken for initiatives that are really not about modernization, but about some other objectives here. For example, modernization is not a greenfield project by definition, because we are not free to choose whatever system requirements or system prerequisites we have. We have a core system capability or a set of such to preserve. We have to reuse as much as possible because legacy applications are a major development time and money investments. They are a major asset to the business. And of course, every business would like to recover and reuse as much of that. So you're most of the time not rewriting from scratch. It's also not a technology experiment. When modernizing, we do not play with new technologies for the sake of being on the cutting edge of modern technologies, right? We at Resolute, for example, tend to err on the side of mainstream and well-supported technologies because typically modernization projects have the same life cycle and longevity expectations for the new projects just like they had for the old projects. And guess what? Web forms is a very solid technology that has been around for more than 15 years now, or even 20. And then the modern applications that we produce today, typically businesses are asking questions like, can this sustain my 10, 15-year development in the future? Well, we have to make sure this is at least as close to the reality as possible, and this can only happen with a well-supported set of technologies that are becoming mainstream, and we see that Microsoft is guaranteeing their long-term support. Another anti-pattern that is very often repeated. Let's use this modernization opportunity to rewrite everything, to make it grand, to make it look awesome, to fix every little problem that the legacy had for the last 15, 20 years. Well, this should not be an opportunity to fix everything bad with the legacy. Quite on the contrary, we tend to focus on implementation changes and then minimize functional changes. What this means, again, circling back to the table stake requirements, your new system can only begin to provide additional value at the moment that it reaches the system capabilities of the legacy. If you can try to project this in your head, the time horizon for this could be many months or even more than a year, in which time you're not really creating significant added value. That's a lot of time for your engineering team to be occupied with matching the system capabilities of the legacy. This is why we want to minimize this time as much as possible, and the fix everything bad philosophy is not helping in this situation. And lastly, it's not a big bang event. We would not hope to sit in a dark room for 6 months or a year, rewrite everything, and then replace it with the legacy in one big swoop and big bang event. On the contrary, the effort should be about gradual write-off, and really the old and the new should be maintained side by side. We deploy often the new pieces, and then we slowly but gradually replace the legacy. Martin Fowler, in his blog post, calls this the strangler fig design pattern, where similar to the strangler figs that really surround the tree and slowly suffocate it, right? This is the same philosophy for the modernization approach, where the new system evolves slowly but surely around the old system, whereas the legacy is maintained as the new one is evolving over time, and at some point replaces the legacy. All right, monolith or microservice, the lifelong question, right, for software engineers. The monolithic architectures that are nowadays considered to be more or less, obsolete in favor of microservices, we do not really see this as so much a challenge today, more than having a clear set of segregated layers in your system. You could have a very nicely layered monolithic architecture that is really maintainable over time, and it can grow sustainably. And you can have a messy microservice architecture with a lot of load in the microservice communication, maybe with a coupling that is so large and complicated that it gets out of hand. So good practices and bad practices in both architectures or both patterns, and we do not really have a strong preference or one size fits all type of a mentality when picking between a monolith or a microservice. But we like to talk about end-tier architectures. So for us, the monolithic architecture is still a very good piece of architecture if it follows the basic end-tier layering. What we create in this architecture is a system design that promotes solid development principles. We facilitate code reuse, we reduce component dependencies, and we limit the impact of breaking changes in any given layer, including technology swaps, because, for example, when talking about the database layer or even the data access layer, over time we see some great technologies coming and going, and it's often a layer that may get replaced as the application progresses. And if you have a well-defined end-tier architecture, this should not be a problem for your overall system, because you are promoting a well-defined and isolated public API through every layer, and the internal implementations could change. Obviously, the most typical example to this is the presentation layer, where if you have a well-defined API facade, you could probably easily exchange or even coexist presentation layers with different technologies, Angular, React, Blazor, MAUI, you name it.
Hey, Veli, if we can just take a quick pause here, because you're kind of hinting at this, and I'm sure you will talk more about this, but in the chat room, Matthew King had a very classic question, which I think is a reality for lots of enterprises. So they have an ASP.NET Web Forms app that is, driven extensively by stored procedures in your data access layer. but they do not have the external pressure to modernize right away. However, they're trying to come up with a new application for which they want to use, all of the latest modern stack, but they want to keep using the same database and the same stored procedures. So as you're talking through it, maybe kind of keep that in mind. And I think this is very achievable. If your data access layer is well designed, there is nothing wrong in reusing it for modern apps as well.
Yeah, excellent point, Sam, and thank you for pointing the question out. I think in a couple of slides we'll see how practically we can approach this scenario. We have compiled a set of categories of scenarios for replacing the data access. Stored procedures or stored procedure heavy scenarios are very typical in legacy applications, and stored procedures are typically a major asset to your application that you don't want to replace overnight. So we are extremely careful about these scenarios, and we have over time compiled a set of practical approaches that add some benefit in your modernization to modern.NET. I'll be happy to address this as we move.
Yeah, well said. And before you move on, I would maybe make a personal, opinion here. We call everything legacy, which sometimes it kind of hurts your sentiments, because something is not legacy if it's running your business today. So maybe it's your present reality, and maybe you are considering moving to newer frameworks for X number of reasons. But don't let people tell you that legacy is always bad, because that's your reality and that's what's running your business, and that's important.
Absolutely, and we are only calling it legacy in the context of a modern architecture because that's the software system that we're comparing it to, right? It's not a legacy for your business, it's a legacy in the context of a modernization effort. So that's the starting point for the project, right? But otherwise, excellent point. It's if it adds value to the business and is actively maintained and you are doing a good job at that, creates a lot of value for the business, a lot of benefits, it's the reality and it's a positive one. Absolutely. All right, so N-tier benefits. A lot of times when talking about N-tier, we outline some of the major benefits of the system or the system architecture that complies to N-tier. I already talked about the solid development principles, code reuse, and the limiting of the impact of breaking change. And those are the purely technical benefits, but we also have a couple of very important business level benefits. And these are that N-tier enables independent work streams, which means that multiple teams, multiple set of engineers can collaborate independently and in parallel over different layers of the system if the protocol for the communication between those layers are already well defined. This happens very typically between the client and the server through a well-promoted API facade or API layer, or even between the database developers and the application developers if your data access tier is well-defined and complies to a protocol that both parties understand. And also, the N-tier architecture promotes technical specialization that allows your developers to get better and more focused at what they do and ultimately increase developer velocity. Right? If you have an engineering team that understands Angular very well, keep them focused on the Angular side while your .NET developers work on the API and then decide the business logic and everything else. Right? Same for MAUI or Blazor, for example. The technical specialization we like very much because this is how we can increase ultimately developer productivity and velocity and time to market. Okay. So how do we go about modernizing a tiered application? Well, we do tiered modernization, where every layer or every tier in the system is approached differently with a different set of objectives. For example, the presentation layer is typically redesigned and implemented. I say typically because we want to change a lot on the UI side, maybe to make it responsive, maybe switch over to new device types and screen sizes. So we are most of the times talking about a redesign and reimplementation. The business layer, maybe not so much. The typical objective there is to refactor and reuse. There's usually a lot of heavy investment in the business layer, a lot of contracts, maybe services, the domain model may be there if you're using domain-driven design. And these are component and even code level artifacts that if we can salvage and reuse, the better for the business and for the team performance overall. And the data access layer is particularly interesting because it's a very sensitive layer for us, where we not only refactor and really reuse, but we also most of the times want to preserve the data access capabilities of the system overall. And we'll see how these are achieved through some of the projects that we do. So talking about data access modernization, so if I go back to this slide, we're going to tackle the modernization principles for these layers, starting from the data access layer, going to the business layer, and then ending with the presentation layer. So a little bit backwards to make sure that we focus on some of the key aspects in each layer. Data access modernization. It's a very interesting topic for us and a very sensitive topic overall for the modernization project in general, because it touches base with your most valuable asset, your data. This is the biggest value every application creates and maintains, because your application is as good as your data is. So typically, data access layers or components, we try to preserve and reuse as much as possible. The general rule of thumb here, and we will see this later on, is can the new system run on old data? If it can, then we have achieved data consistency between the old and the new, and then we can safely extend the data capabilities or the business capabilities of the system. The typical migration efforts that we see at the data access level is migrating to most of the times entity framework, or typically to some kind of an object relational mapping framework. We also do a lot of refactoring. So refactor data access code, if you don't have an NT architecture that is well segregated in your typical web forms application, then a lot of times refactoring into entities and services is an effort that has a lot of returns in the future. We very often convert projects to modern.NET. In the data access modernization layer, these projects are typically your contracts, entities, business, data access layer, anything to do with your actual database access, whether through ADO.NET drivers or through other, client library that you have for your database technology. We update those to modern.NET along with all the dependencies. Testing is a major requirement for your data access modernization. We need to test for breaking changes. We need to test for data consistency and for obviously performance. When we test for performance, we analyze a lot of the query performances, the SQL statements. We run some transactions to see that your application can deal with the real life data that your users throw at it. Let's look at some of those principles in a little more detail. Data preservation is the basic philosophy of sticking to your current relational database management system and database schema. If you can evolve your new system around your old data, you have achieved data preservation, which is the basic tenet of your table stake requirements. You don't want to break the data consistency. You don't want to prevent the users from performing the same data access and modification operations that they had access to previously in the old system. If you can answer positively to the question, can the new system run independently on all data and provide all data operations the legacy does, then you have achieved pretty much your modernization objective for the data layer. Entity framework is your friend. Well, entity framework, or pick your own object relational framework here. We don't care as much, although entity framework is very solid. We highly recommend it. But you need to have an object relational mapper. Why? Because you're working in C# in objects, and you want to make sure your data is represented as objects in your code. So an ORM is always your friend. Entity framework, we like it because it supports the most popular relational database products. It has quality drivers for everything that you may need, as SQL Server, MySQL, Oracle, Azure SQL, Cosmos DB, you name it. We also like it because of its principles of eager, lazy, and explicit loading. When you dive into the principles of an object relational mapper, you very quickly hit the first major problem with relational databases and their mismatch mapping to objects. What do we do with related entities? Entity Framework solves this nicely with the principles of eager, lazy, and explicit loading that allows you to control granularly how your entities are materialized in memory and in your C# objects. And also, Entity Framework is very good for migration to modern.NET if you already have a legacy version of Entity Framework working in your web forms application. It's well documented. Microsoft has a nice set of articles and a tutorial on how to migrate from, let's say, Entity Framework 6.0 to Entity Framework Core 6.0, and it's pretty straightforward. So your data equals your entities plus your services, or how do we like, or why do we like to segregate data at the code level or at the data access level as a set of entities and services? Well, firstly, because you are working with with C# objects, with POCO objects that represent your data tables. Student, grade, these are relational tables in your SQL database, for example, and you are materializing your table rows in C# instances. We also have, in Entity Framework, we have the concept of a database context that comprises the set of all database entities and their relations that your database works with or provides. So this is a combination of all your tables and entities in one. And then we extend this typically. This is not an Entity Framework concept, by the way. This is something that we see working quite well for most modernization projects. We recommend extending the data access intricacies or implementation details in a set of services and interfaces that really combine the different classes or different entities and context, database context that you need for materializing a particular data set in memory, right? For example, the student service, it may have a method for getting students in a particular grade, and the student service class works with the Entity Framework database context and then uses some queries to materialize a bunch of student objects in memory. Why do we like this approach? Because if you code against interfaces and not implementations in the, which is also one of the solid principles that promote good system design, this means that your student service could change its implementation in the future and maybe have its implementation replaced with another data access framework or even with a different storage technology altogether. If you satisfy the same public interface, you can preserve your clients unchanged. So you minimize or limit the scope of breaking changes at your database level or data access level. So your services, they promote query capabilities through method signatures, and then they send and receive entities as their public API profile.
Hey, Veli, sorry to interrupt, but maybe we have another 10 more minutes before we switch over to talking about MVC and Blazor, but a couple of quick questions here for you to address. Marian Sagerman was talking about how Entity Framework can sometimes be painful if you have a lot of like stored procedures that you're trying to update and it breaks the the model object. Any pointers on how how to do better?
Absolutely, yeah. So what we have seen through experience is we have a different position of those scenarios in what we call the code reusability scale. From a scale from 1 to 10, 1 being almost no reuse or we have to rewrite it, to 10 reuse everything, we see stored procedures to be somewhere in between. Why? Because if you have invested heavily in stored procedures, then your chances are you're better off keeping them and then creating entities or entity classes programmatically or imperatively. This helps because you're still working with objects at the C# level, but you also preserve your SQL stored procedures. So in this case, you have to do it with ADO.NET. You probably cannot use NT framework directly, particularly if your stored procedures are used for get statements or for select statements for read operations. But we still see a moderate level of reuse, particularly you reuse all the stored procedures, and maybe at the C# side, you end up rewriting or writing some entity classes to make sure results of those stored procedures are materialized in code. And then on this scale, you can see the different scenarios. For example, the worst case scenario that we have seen typically is the ASPX SQL data source component, which is a UI level component that is defined in the ASPX markup and has SQL statements straight in the markup. This is the worst case because you have SQL in ASPX pages that typically has to go somewhere else. And most of the times you're probably better off just switching to NT framework and redoing your entire data access layer from scratch. And obviously the best case scenario is if you have an older version of NT framework that you are migrating to a newer. You already have your data model, you're working with entities that are defined by the entity framework, and then you have a very straightforward migration path. All right. So that was for the data access layer. For the business layer, what typically we care about at the business side is, can we refactor and reuse contracts and services, right? So if you have, again, if you have a well-segregated NTR architecture, chances are you already have contracts, you already have implementations. This means that you have already done yourself a great service back in the day because your migration job just got a whole lot easier, right? You have to migrate to specific .NET version, to modern .NET. Typically, the interfaces and the contracts are migrated to .NET Standard because you want them to be highly reusable. A lot of projects depend on them. And then the implementations are typically migrated to a specific flavor of .NET that you're targeting for your deployment environment. One thing to have in mind here is most of the times these dependencies, these implementations have dependencies. A lot of times external NuGet packages, for example, we have to watch and make sure that they have their equivalent modern .NET versions so that the modernization or the migration is as smooth as possible. Very importantly, we typically want to test the domain model to make sure we don't have breaking changes at the business logic layer. This is very important. Unit testing will suffice here, but by all means, we do highly recommend testing your domain model formally with a bunch of unit tests that you can run against the old and the new system in parallel. And this is where API design comes in as well. And Sam showed in the beginning a very nice little tool for designing your APIs for rapid prototyping. If you have REST-based APIs or even RPC or function-based APIs running on HTTP. And over time, we have also seen WebSockets to be a great alternative to HTTP APIs. And the WebSockets are very good for both real-time communication and as your client-server, API signature generally.
Hey, Veli, so before you move on, since you're talking about contracts and APIs, so in the chat room, Vlado Velkovsky was asking about, SOAP web services. We remember the WCF days, right? So they have something in VB.NET. They're trying to move it to .NET Core and have them run in Kubernetes, right? So any pointers on that? So again, my 2 cents is, look at, the contracts that you have right now. See if those contracts can be reusable, for defining new APIs that you can, publish, and then where you're hosting it in terms of microservices. Like you can host it anywhere, and sure you can do it in Kubernetes. But really, any more pointers? Like if you're moving from like SOAP web services onto newer business layers.
Absolutely. So we have worked on similar scenarios in the past, and the 2 scenarios that we have primarily seen working. One, if you can preserve your SOAP services as a standalone component, great. We highly recommend doing that for the time being. WCF components, SOAP components, do not have direct replacements in the modern .NET world. So you either have to replace them altogether, which means rewrite, or what we recommend is isolate them and create an API facade on top of them that is more geared towards modern web development. For example, REST-based API, or not REST-based, it's going to be RPC-based, most probably because you're going to be calling classes and functions, but at least make it work over HTTP and JSON and not over XML with the SOAP protocol. What this allows you is this exposes the SOAP API to modern application frameworks like single page applications, Angular, Blazor, whatever you may have, and it gives you a little more time to think about what we do with the SOAP layer in general. And over time, typically you end up replacing the SOAP layer with a different type of an API implementation. But you also have the option of not making it a priority for this moment by isolating it and then creating a very thin HTTP and JSON facade on top of that.
Yeah, well said. Now we are getting a lot of questions, which we would love to come back towards the end because we want to, talk through. We talked about the data access, the business layer. I think Ed wants to talk a lot more about UI. So how about Veli? How about in 5 more minutes we try to switch it over to Ed?
Absolutely. I think we can fit into that. So I wanted to finish this section by showing another scale here. This time, this is the refactoring complexity scale. What we see here is typical NTR architectures have varying degrees of refactoring challenges or refactor and reuse ability when modernizing from legacy web forms to modern.NET. The worst case scenario is SPX code behind deals with a lot of UI events and input sanitization only. Sorry, this is the best case scenario where very little refactoring is needed because your NTR architecture is already there with entities, services, and interfaces, and those get migrated directly to modern.NET. The worst case scenario, business logic in your markup, code behind, no data services. We have seen a fair share of that. ASPX pages with code behind files that are sending SQL statements built with string builder in C#, getting ADO.NET dataset and data table objects, and then materializing properties of or cells from these rows in the UI. This means no entities, no services, not even interfaces for exchanging data with your database. So all of that will have to be refactored and go into separate projects. A lot of work majorly. All right. So code dependencies, I think also a very important aspect here. We have to put the code in the right place and understand the impact of change through the solution. So this is the typical concept of the coupled architectures. You want to make sure your dependencies in your system are manageable. You understand them very well. By all means, avoid circular dependencies. You don't want 2 modules depending on each other and creating a circular reference. And then we typically see a good practice here in the concept of dependency order, or every module in your system has a particular order in the dependency chain, and then modules can only depend on other modules with a lower order, cannot depend on modules with higher order. This creates kind of a tree-like structure for your dependencies, makes it a little more manageable. We have different tools that can help us here. Visual Studio Code Map is great, and Depend and ReSharp are typical commercial tools that we use in this space. All right. And finally, UI modernization. This is the more visual aspect of the modernization, a little more involving typically because most of the times we end up rewriting and minimum reuse in general. If you are working with MVC already and looking to migrate to modern.NET, chances are you're reusing a lot because your Razor pages already in MVC are already there and you may preserve them. But in the most typical web form scenario, ASPX pages do not lend themselves very well to reuse. So most of the times you end up rewriting with some modern application framework like Blazor or Angular, for example. This is also the time to do UX UI redesign. A lot of times we impose new set of UI requirements to the Modernize system. We need multi-device support, we need touch and voice. Web forms comes from an age where those requirements were not there because the device capabilities did not simply exist. Also, we most of the times go single page application nowadays. On the JavaScript side, we see a lot of Angular, React, and Vue work. On the C# side now, Blazor is a great choice. It's come a long way since the last year or so, and it's a major framework, UI side framework for working with your .NET application. Or typically, we may also stay server-side with MVC and Razor pages. That also works. We see a lot of good examples for preserving the server page paradigm and then reusing a lot of your existing assets in the legacy application. Finally, some modernization pitfalls that we see. Server pages for rich, interactive, responsive UI. Well, this doesn't seem to lend itself very well most of the time because server pages are document-centric pages and they're not as interactive as sometimes your single page application can be. Yes, they can be made to be very interactive, but this also creates a lot of additional requirements for JavaScript and really a front-end architecture that you have to write on your own. Or another very common pitfall, Blazor for C# only application development. We like Blazor, we do a lot of Blazor development, but we don't see the fundamental proposal of write C# only in the browser to hold true. More like we see Blazor to be a good paradigm for combining C# and JavaScript for front-end application development, and we make it work daily in our projects. Obviously, data validation client-side only. You don't want to do that. You want to have the same type of data validation on the server. And very importantly, you have to capture API requirements early on. If your API development starts by the time your front-end development starts, you're already late with the API development because you have to have the communication contract between the client and the server already established by the time UI development starts. Obviously, UI development is complex. You have to envision some of that complexity and prepare to meet that. There's a lot of little, nitty and gritty details that, hit your development team as you move on. Thank you very much.
Yeah, that's a lot of things. So what I'm hearing, Veli, as you talk through it, is essentially, if you want to modernize, like clean up our act a little bit, right? So clean up your code base, get it ready for, moving. So and that's good advice, architecturally, anytime, even if you're not considering modernization, separate your dependencies, have a nice, flow. So one quick question. I mean, there are some like general questions which we would love to address towards the end in terms of broader modernization strategies. But Gary McGlennon was asking if Entity Framework supports in-memory mock testing. Is there anything you know about this?
You may have to check the reference here. I don't have the answer to this question off the top of my head, but Entity Framework does support a lot of good patterns for marking your database context and providing marked data if you want to test your entities or even test the domain model working with your entities.
Yeah, and Ed, you might want to weigh.
Yeah, EF Core does support in-memory database, but the last time I used it, it did not support certain relationship models. So it's very basic. I think it's to keep the memory footprint low. So it's kind of like a flat, single table that you can mock. You can't do full relationships with it. At least the last time I used it.
Yeah, it makes sense. So Ed, if you're ready, so we talked about architectures, and Veli mostly talked about the data and the business layer. The UI layer is also very, very important, and like Veli said, that's a lot of the visual aspects of this. So Ed, if you're ready, I'm going to let you drive the screen and share your desktop and walk us through.
And I'm going to try to address some questions as well as we go through this. There were a couple things that I kind of flagged for later as we moved along. I'm going to talk a little bit more about the front end of things, but we did have a question that from Michael Davis said, I have several .NET 4.8 web form apps using Telerik components, SQL Server. Says he's a small shop, meets 100% of his needs, but they're considering new platforms because of the limited life of .NET 4.8. And they're trying to decide which way to go, what's the most minimal effort with their with similar capabilities to what they have. So I'm going to show some of the front end stuff that you'll be able to transition to. Regarding web forms itself, there's going to be some rewrite of those, and I think Veli covered that. Is somebody saying my sound is bad? Am I coming through loud enough? Do I need to turn up my microphone? Is anybody on our
maybe just turn it up a
production
notch.
team?
Yeah, and while you're doing that,
second to adjust.
Yeah, and while you're doing that, just a general, a lot of you folks are asking about this being recorded. So yes, and we'll put this up on YouTube. And in terms of the content itself, our slides, if that's something you want to, go through, we are happy to, maybe write up a blog post on, Telerik blogs, which has all of the content for today. So you can, browse through and, remind yourself of some of the things that Veli and Ed talked about.
So saying the transition from web forms, you're going to have to rewrite some of your view layer, and I'll be covering some of the different view options that you have with .NET 6. And I think Blazor is going to be one of the better options there. It looks a lot more like web forms than some of the other things like MVC and Razor Pages. And then I also have a question about refactoring some or migrating from MVC to .NET 6, and I'll cover that as well. So one moment, let me get good old WebEx to get off my screen so I can see what I'm presenting. And let's talk about ASP.NET versus ASP.NET Core. So with ASP.NET, we're talking about .NET Full Framework, or .NET 4.62 and up through 4.8. So this is the matured ASP.NET and .NET platform that only works on Windows, right? So when we talk about ASP.NET Core, we're talking about a version of .NET that is cross-platform and open source. It is very performant. You're going to see a lot of performance increases over the previous version of .NET. This is one of the things that .NET teams work very hard on, is making sure that ASP.NET Core is like the key performer in the web space. They have benchmarks to back that up. I won't go into all that today. That's not what we're here for. Dependency injection is built in. Configuration improvements have been made. Overall, it's just a lot easier to work with ASP.NET Core. It's easier to configure. It's easier to do DI. All that is given to you out of the box. The middleware pipeline has been kind of rewritten. They started that back in MVC 5. We'll talk a little bit about that as well. And we have modern front-end frameworks to work with. We have several of them. I'll go into details on each of those options that you have. We also see a lot more of a rapid release cycle, where the full framework, we're going to be staying on .NET 4.8. There's not a lot of innovation happening there, but again, it's a matured framework and it's stable. With the .NET Core platform, we're getting a new release every year. So if you're looking for something that is adding new features that you can take advantage of, then .NET Core is definitely the future. Some more benefits of ASP.NET Core. It's got a unified story for building web applications and web UIs. So we'll talk about this a little more specifically. We have several different ways that we can write our UIs, and they all can be kind of interchanged in different scenarios. It's easily testable. It's a bit more separated as far as concerns are than previous versions of MVC and ASP.NET. So it's definitely testable. We have Razor Pages, which are very focused on like feature slices. So that lets you be really productive. It's really cool. I'll give you an example of how that works. And of course, Blazor, letting you use C# in the browser alongside with your JavaScript. So you can take advantage of C# libraries that you know and love already, as well as some of those JavaScript tools that you might be using. We also have the ability to do cross-platform. As I mentioned, we have Windows, Mac OS, Linux. We can run ASP.NET Core on all of those. And then more specifically, when we get into things like Blazor and MAUI, we can develop for the mobile devices as well, and the Windows and Mac desktops, which is really cool. It's open source, community focused. You can go out there, submit a pull request on the ASP.NET Core platform and try to help out, or you can just see how things work internally. Maybe it'll help you solve a problem you're having. We also have more future-proof things like gRPC, which is growing in popularity. That is also baked into ASP.NET Core if you're interested in that. So ASP.NET MVC, if you're doing a migration from one of the ASP.NET MVC full framework versions to ASP.NET Core. So you're going from .NET MVC 3.3, 4, 3, 5, etc. to MVC Core. Here's some of the things that you're going to run into. And there's some help out there to get past some of these things. So first of all, I recommend looking up the .NET Upgrade Assistant. This is going to help you analyze your project and see where you need to make changes. Do expect some breaking changes, and those breaking changes are going to come in the form of your app startup, your app settings, the way static file hosting is done, the way dependency injection is handled, and the way routing is handled. One of the big ones that I see is with the app startup. We used to have the global ASPX file. Now we have the startup.cs type of behavior. So you're going to have to migrate a lot of your startup behaviors over. And there's some really great guidance on that .NET Upgrade Assistant website. And there's even a full ebook there to help you with that process. Some of the things that do transition over, though, are some of your view logic. Depending on how that is written, if it is separated properly, then you have some things that are generally unchanged. It's HTML, it's CSS, and in some cases it's JavaScript, and those things are not going to change from one .NET version to another. So if you have HTML helpers that are that don't have any specific business logic that is tied to that .NET full framework, then those things can actually work just fine in ASP.NET Core. One example is our Telerik UI for MVC component library. That works on .NET MVC 3.5, I believe, through MVC Core. So something like that is a very component-centric library is going to work on both platforms. And then if we talk about specific UI elements or choices that we're making with ASP.NET versus Core, on full framework, we have web forms and we have MVC up to 5.2. On ASP.NET Core, we have MVC Core, we have Razor Pages, we have Blazor. Notice we don't have web forms here. So we do gain some new front-end UI options here with Razor Pages and Blazor, but web forms does not make the cut. So you will have to rewrite some of those web forms applications. Let's talk a little bit about MVC in general. If you're coming from web forms, you haven't looked at this yet. We're talking about model view controller. So we're talking about a clear separation of responsibilities. We're going to have a set of code that is our model or data model. We're going to have our view, which is our UI logic, and then our controller, which is doing business logic, fetching data, those sort of things. It's very testable because of these separations. It's very flexible. You can add things in and out of this very easily because of the pluggable MVC pattern here. The UI in the scenario is server rendered, and we use JavaScript for interactivity. A lot of times this JavaScript is written with jQuery. The view engine that we're using is Razor. It lets you write in a C# syntax to build your UI logic. Again, it's rendered server side. That's really important here. We'll talk a little bit about why that is in a minute. Using some jQuery to make that interactive on the client side. And then in ASP.NET Core, we have some choices here. So in Core, we have HTML helpers, which use that Razor syntax, that @ symbol. Then we'll say HTML dot some component. We also have tag helpers, which is a tag and attribute style way of annotating our components. So this is very HTML-like component logic. They're very easy to write, very testable. And then, of course, we have Razor components, which come from the Blazor framework itself. Those are actually compatible with MVC, and we'll talk about that, and I'll show a demo in just a minute. We also have Razor pages. This is a kind of a brother or sister to MVC, you could imagine. It doesn't have that separation of concerns by model, view, and controller, but instead by feature. So instead of having separate folders, and you may have a model for a feature and then a view for that same feature and a controller that handles that view and model for said feature, Razor Pages combines all of those things into one file, or sorry, two files rather, a view file and a code behind file. So this is getting a little bit closer to that web forms feel. But it basically has a small like MVC style application, but in that one feature that you're building. So it's very MVVM like rather than this MVC style. And again, those are also rendered on the server and use JavaScript. And these Razor pages are compatible with MVC as well. So you'll see a lot of similarities here. We use HTML helpers, tag helpers, and possibly Razor components to build out our Razor pages, but we don't have that big separation of concerns. Rather, we have a separation of features. Then we have Blazor WebAssembly, and this is one of my favorite things to talk about. So this is running .NET in the browser. It all uses web standards. We'll get into the details on what that means in a minute. These are rendered client-side. So rather than rendering them on the server, like the other two UI options that I mentioned with Razor Views and Razor Pages, these are rendered on the client side. So it's a SPA application or single page application. This is a lot like your Angular or React front-end applications, but you're using C# instead of JavaScript. For me, I feel like this is a really low learning curve for .NET developers because you are writing a lot less JavaScript, and you may not need those JavaScript build pipelines and configuration tools. You're going to use a lot less NPM and Webpack and all of those things if you're using Blazor. So the style in which these components and pages are written also looks a lot like web forms, even though it doesn't have a view state and things that web forms has. It's a really great transition point from web forms or Silverlight because of just the style of coding that you're doing. Now we also have another flavor called Blazor Server. We'll deep dive into this one as well. It's the same framework as Blazor WebAssembly, but it's not running on the client with WebAssembly. Instead, everything is rendered on the server instead of the client. It's still a SPA application, but the logic is being handled on the server side, and it's using a clever WebSocket technology to make this seamless to the client. So you could think of it as a thin client type of way of doing Blazor, and it's really great, in my opinion, for line of business applications. It lets you write applications very quickly because there's some opportunity here to write less code depending on what your application does. You may not need a web API layer. You can build proof of concepts and things very quickly with it. So let's talk about the UI component model for Blazor. Now, Blazor uses Razor components, which look a lot like traditional Razor views and pages, but it uses something called a render tree. Now, this is a real fundamental change. The other two platforms that I talked about, MVC and Razor Pages, they, at the end of the day, an oversimplification here, their component model creates strings, which are HTML. Blazor creates a node graph, which is called a render tree. So these things are handled quite differently. So there, you'll see in a few minutes where they can and cannot be interchanged. It also uses that Razor style syntax, the opportunity to render on the client, and again, C# over JavaScript here. Now, these are all one big happy family in ASP.NET Core, and you can mix and match some of these things. So if you're using MVC or Razor pages, say you've transitioned from, you've migrated from .NET Full Framework MVC to .NET Core MVC, and that is successful, and you want to take advantage of some of these other view models, you have the option here of HTML helpers, tag helpers, and Razor components in an MVC application. That goes for Razor pages as well. When we choose Blazor, we cannot interchange HTML helpers and tag helpers within the Blazor component model. It's just the way that Blazor renders things with that render tree doesn't allow for that. But when we're using MVC and Razor pages, we can render those components within those frameworks. And I do note here that it does require some Blazor dependencies to do that with Razor components. I can show an example of that, but it's a nice transition point if you're interested in moving from .NET Full Framework to MVC and then starting to then transition into a Blazor application. You can start creating these Razor components, take advantage of that C# component model, do away with some of the JavaScript that you would normally have to write, and then later on reuse those components in a full Blazor application, or even something with MAUI, which we'll get into in just a moment. So let's take a deep dive here into Blazor. Blazor is this brand new framework using C# that runs HTML in the browser. We'll go just lightly on the facts here. It is client-side C# when you're using Blazor WebAssembly. WebAssembly is a web standard technology, so there's no installation of things like you would get with Silverlight and that sort of thing. It's not a plugin. You don't have to have anything special in the browser, as the client doesn't require any sort of installs or plugins to make this work. While it's not web forms, it is web forms like, but it is a completely new code base that has been rewritten from scratch. I think the resemblance of web forms comes from the fact that it is .NET, and we're just doing a lot of things that we do the .NET way in here. And it's not transpiling any JavaScript. So this is .NET code running in the browser. It's not there's no magic here like TypeScript turning this into JavaScript somewhere. And Blazor is kind of an end-to-end solution for web UI. It comes with the same dependency injection model that we get with MVC and pretty much any .NET Core application. The component model is super robust and easy to use. It's way easier to develop components, in my opinion, than it is to develop components for MVC and Razor pages. HTML helpers and tag helpers, while they're pretty intuitive, Blazor is just one of the lowest learning curves I've seen as far as component development goes.
Hey Ed, maybe
yes.
Check your volume one more time and bump it all the way up, please.
This is going to haunt me today, isn't it?
Maybe in the meantime, I can address an interesting question that was asked here in the questions panel, and this was to compare Blazor with Silverlight, because essentially Blazor is in the same boat like Silverlight was back in the day, running in the browser and promoting C# and .NET in the browser, right? And the question was, what guarantees that Blazor will not follow the same fate as Silverlight, right? And obviously no one can foresee the future. If we had a crystal ball, that would be awesome. But I think one thing we can say for sure is Blazor is built on standard technologies that are well supported by modern browsers like WebAssembly. WebAssembly is a cross-platform, cross-browser interoperable specification for stack machine runtimes that could be implemented in the browser. So essentially it gives you the ability to run C# or C++ or Go or Python in the browser alongside your JavaScript runtime, right? And it's standards compliant, meaning that it's likely not going to go away anytime soon. So Blazor is safer in this regard than Silverlight was, because Silverlight was based on ActiveX, which was by and large considered to be quite insecure or less secure, and ultimately deprecated from major browser implementations. So a little bit better there, I would say, in terms of future-proofness. And obviously, we have Microsoft's enthusiasm here that is betting majorly in Blazor as their C# in the browser implementation. So I'm quite more optimistic in this regard.
Yeah, well said. And both of you have mentioned Silverlight. I spent like a couple of years with Silverlight, and it's a different ball game. Like Veli, you said, like it's really standard. And there's nothing else going on in your browser that you need to worry about. And then while we are waiting, oh, Ed, are you back?
Yeah, I'm back.
Right.
So if you want to try Blazor and you don't want to install something on your local machine, maybe it's something you don't want to install at work, you don't have a computer at home set up for this, you can actually go to blazorrepl.telerik.com and you can write, run, share Blazor examples right in the browser without installing anything at all. No accounts required. It's a completely free tool that is out there. So I just suggest giving that a try if you want to mess around with the Blazor programming model. Just try some things out without having to install anything on your machine. You can do that right there in the browser. And I think we had a pretty good discussion going on of what Blazor was like in WebAssembly and how how it uses WebAssembly and doesn't need plugins. So if you look at how a web application works currently without Blazor, you get your JavaScript and the browser parses and compiles that JavaScript, turns it into bytecode, does all of the interactions with the DOM. WebAssembly comes in and kind of short circuits this process. So we have bytecode that has been compiled externally to the browser. And this opens us up, as Veli said, to different programming languages like C#, Go, Rust, etc. And we can compile those things into WebAssembly. And this is the engine that WebAssembly runs on, or sorry, Blazor runs on. It is a .NET, or the .NET runtime running inside the browser. So we're actually executing .NET code in the browser, Blazor being one of those libraries. And then your application code as well is a .NET library that is running client side. And we also have the option to run Blazor server side, which just gives you a small payload of a JavaScript framework that sets up a Signal R connection with your server and basically treats the browser like a thin client, where that thin client is doing all of the communication back and forth with the server and updating the DOM. Now, if you compare the two of these models, you've got the client-side Blazor, which is low to no server overhead. It's a RESTful scenario that we're used to using with something like Angular or React. It can work offline. It can be a PWA application. It does have a little bit larger of a payload size because we are, in fact, sending the .NET framework down to the client. It's RESTful, so it is a disconnected environment. So it's typically what we deal with on the web. But I'll get back to that in just a sec, because we talk about server-side Blazor. It has a smaller payload size because we're doing all the work on the server. We're essentially just sending over deltas or updates of what changed in the UI. So there's not a whole lot of data transfer back and forth here. And there can be a lot less abstraction with server-side Blazor, depending on what your application needs are. You can write services in your Blazor server-side application that talk directly to your database. You've got everything right there in the application. There's not a necessity for a web API unless you have some companion application that's accessing some of the data that needs RESTful services. So you can build, if you don't have a need for REST or web API, you can build an application without those things using server-side Blazor, if that's something that is attractive to the type of application you're working on. You're also pre-rendering. Yes.
Yeah, before we move off from the screen, a quick question from like Stephen John Edward on exactly the payload size in comparison, comparing it to like Angular React. I know like this was a lot of like IL linking, magic, and tree shaking. Where is Blazor Wasm right now?
It's still around a meg to a meg and a half.
So it's a little bit over like the Angular React, but again, depends on the app, like a Hello World app, right?
Yeah. Now, if you compare Hello World apps, it's not really apples to apples comparison in my point of view. When you build a full application with either of these frameworks, what I think is typical is with Blazor, you start with a little bit of a large payload, but that application size doesn't grow that much over time because the application code that you write isn't that big once it's compiled. The .NET framework itself is rather large, but your application code isn't. So you start rather high, but it stays about the same. With a JavaScript application, you start very small. That Hello World application doesn't weigh very much, but the more code you write, the more JavaScript you add, the larger that application becomes. And then over time, you start to see those two things kind of level out as far as like application size goes. That's my opinion of how that works. If you tried to compare like Hello World of say a React application and a Blazor application, the Blazor application is probably going to be a lot bigger than the React one. But at the end of that, development cycle, those two things aren't going to be wildly different, in my opinion. Let's see. What are we doing on time? I was going to get into some Blazor demos. Before I do, let's talk about hybrid apps with Blazor as well, because I think this is really cool. This is more of a future-proofing thing. This is still in preview, but essentially what you can do with a Blazor application is you can put this Blazor application in a MAUI shell and run the Blazor app on your desktop or in a mobile application. And this runs, or this is a real desktop application running a web view with Blazor application code inside of it. So Blazor then, by proxy, gets access to native device APIs. So you can do things like access the disk on your desktop or access the drive on your mobile device, access camera features, accelerometers, all of that type of thing from C# code in web UI code, which is a really interesting way to take your existing web technologies, skills, and keep transitioning those. So you can use your skills to develop native desktop and mobile applications using the web UI technologies that you already have. And this can help reduce your dev time. So let's take a look at some demos real fast here. I know we're getting short on time, and I did not mean to load Teams. I meant to load Visual Studio. This is kind of the, let's pull this one up here. This application is a Blazor application, and we'll go ahead and run. Let's pull up the server here. I don't want to update now. And wow, this is all happening live. Thank you. Things that happen when you don't test them in the morning, or when you test in the morning before the show starts, and then updates come out during the show. Let's start set the server as our startup. And this is a full stack Blazor application. It is running some Telerik components as well. And let's get this up and running. Come on.
So while you're waiting for this to come up, Ed, I mean, there are more questions on, the classic MVC to Blazor. So I would love to know your, point of view. You mentioned like Razor components is a good way to move because you're bringing in more C#, and then that's going to be an easier transition into Blazor. But like any other pointers you can, throw out.
So if you're coming from a web forms background, the way that these Blazor applications and component systems work feels very similar in the way you say describe some components. So in this example, we have a Telerik data grid. It's similar to the way that you would write a data grid in web forms. So you have a component that is a data grid. You set properties on that component and give it data and light that component up. What you don't get from the web form style of things is kind of like a drag and drop experience. We don't have that, but the way the components are described with tags and properties are very similar. With Blazor, the model of creating a component is so simplistic. I think that's one of the things that draws people like myself to it. If we just jump into Blazor REPL for a moment, we can just create a component very quickly here in the browser in Blazor REPL. And basically, any markup that you put inside of a component that ends with .razor, this is now a component that I can go back into my application and just add to my application. So I called that my component, and if I type my component in here, this is now a component in my application. Did I make sure I spelled that right? And we'll go ahead and just run this. And now that I have my component, it will render my component there. And I can also write C# code in this same file and create an interactive experience with that component. And I can expose properties and so on. And those properties then get set right at the component level. It's a very, very simple way of describing components. I think that's what makes Blazor so powerful and easy for .NET developers to pick up and just run with. And if we look here, we've got HTML mixed with our component logic using the Razor component model. We have Razor syntax here. We're injecting services. These are all very .NET centric things. So we can just say @inject, bring in a service here. This could be an interface even. And the dependency injection system will resolve that service. And then we can simply call that service and get data from it. Behind the scenes, this is just using HTTP client. So again, things that we use in .NET already. So you can see the service here is calling get from JSON async and post as JSON async. Those are things that are very familiar in the .NET world. We're not writing JavaScript code here to go fetch data and then take that JSON response and do things with it. We're actually getting back the JSON response, and it's automatically being serialized into .NET objects for us, so we can work with that data inside of our components very easily. So we can take that and just bind this weather forecast data to our data grid, and that's what you see being displayed here. And then we can do CRUD operations, edit, update, delete, those type of things. Again, if you look at the amount of markup or the amount of code for this, it's very simple. We're just grabbing services, pulling in data, and then pushing objects back out to the data service. There's not a lot of code inside of this this page here, thanks to the Blazor framework. Now, if we have an application like this, it's running perfectly great here in the browser. It's using C#. There's not any JavaScript in this application. We've got charts and data grids, forms, all the things you need to build a web application. Let's say we want to transition this later on to a desktop application. Something that's coming with the next release of .NET is something that you talked about earlier, Sam, called MAUI. Now, my application here, if I can zoom in, I've got my client server and shared project. This is all my web application. I'm going to come in here and I'm I'm going to run from the command line just the server portion, just so I have the web APIs running. I don't need the views and all of those things. I have a project reference set up in this MAUI application that is actually just referencing the client application here. So I have a project reference that's going to pull in all of the views, the routing, everything that I've written for my web application, and I'm going to make a desktop application out of it just by adding a project reference and changing a couple of the services that are in here to make sure they point to the right services. And then if I run the MAUI application, you'll see the same application that we saw in the browser, but this is running natively on the desktop. It's no longer using WebAssembly on the desktop. It's using the .NET runtime that is on my local device here. And in the case of Windows, that's the full .NET Core framework. So this is all .NET 6 right here. It's very responsive, extremely snappy. This is a desktop application. I could go ahead and add additional services here in my MAUI app that could do offline caching to disk, send local native push notifications, use tray icons, you name it, any of those Windows API things that I would like to use here, I can actually use in my Blazor app now. So this is a very future forward way of thinking about building your applications. If you're already considering migrating to .NET 6 and you want to take advantage of Blazor, then further down the road you can take advantage of MAUI and then keep expanding on the longevity of that application.
Yeah, Ed, we have a lot of maybe questions to kind of dive into, and I'm excited by this. We normally don't allow cool web kids to do desktop, but I'm okay with this because you're bringing in as a web view and you're bringing in Blazor. So Ricardo in the chat room was asking if the hybrid app model is using server side. So yes, there's no WebAssembly here. It's just, I mean, the client and the server are in the same spot pretty much, so it's all server side. So Ed, do you have any more things to show, or do you want to switch to Q&A?
I'm going to make this super quick. I did mention that you can combine Blazor with MVC. So in this example, I have an MVC application. You can tell this is an MVC application by the CSHTML files here. So Blazor uses .razor. There's a clear separation there of what those component models are because of what I mentioned earlier with the way that those components are rendered. A Razor view or Razor Razor like HTML helpers, all of those things, those emit HTML at the end of the day. Razor is a DOM abstraction. So it's creating a model of what the DOM should look like. Those are two wildly different things. They have different extensions, but this is an MVC application. I want to use a Razor component, a Razor component from my that Blazor world or Blazor model in my application. There is a component tag helper for MVC and Razor pages that I can use, and I can say component. And here I've got a counter component, which is written in a Razor component syntax. I'm going to set my parameter initial value to 0, so I can set parameters when I render these things, and then I can set the render mode. So I'm going to render this one server side because my MVC application is rendering components and views server side already anyway. I'm going to go ahead and use a server side pre-rendered way of rendering this. You could also render it on the client. There are options here. We'll go ahead and run this page, and you'll see that I've got both a Razor view and a Razor component working together on the same MVC view. So I can interact with my component. It's rendered right there alongside the other content that was generated by that CSHTML page. Now, that counter component might not be the most impressive thing. So I've got another Razor component that I wrote. Not a lot of code in here, but this is using the Telerik editor and some NuGet packages to make a Markdown editor. So just this little bit of code here, I'll actually be able to import Markdown from the web into an editor right in my browser here, I'm going to take this index page. We'll take the other code out of here, and we'll change the component to be a markdown editor. I don't need to set any parameters on this, and I'll let it be server-side pre-rendered as well. And we'll go ahead and run this again. And just using that component tag helper, I can pull in this experience here, where I can come and import. Maybe running into a firewall issue or something, but you can edit Markdown right in the browser, and you can create an entire feature in that Razor component syntax, and then pull that component into your application just with a simple tag. So if you want to stay in this Blazor world, you can build multiple components, combine those together into an experience, and then just bring that component in with that one component tag helper and fill out that page with all the interactivity you want. And,
good stuff. Good stuff. I also have a couple of questions around this, but Ed, why don't you wrap up in the next 1 or 2 minutes, and then we'll switch to something.
Oh, that's all I have, Sam.
Okay. All right.
I'm good for questions.
All right. So let's go back and see if I can take the control back. I don't have anything, but just to wrap things up. All right. So we kind of started with Veli talking about architectures, right? I think this is important because no matter what you're doing, for today, or you want to move to a newer framework, this is going to be key for you to have a clean code base. So you do not have those circular dependencies, and you have things nicely, your separation of concerns are nicely separated out. And we talked a lot about the UI layer, with Ed, MVC, Core, and Blazor, lots of things to kind of think through and see what works for you. So let's try doing a couple of questions, and Veli, feel free to chime in if there is something that you really want to answer. But there are a couple that I had marked out here. So Sandy Hong was asking if an app is just designed for basic CRUD operations. Ed, is Blazor a good model, or could you do with like Razor pages? What's the way forward if you just wanted to move and shift a simple CRUD app?
From what?
That wasn't said, but let's just assume like MVC or even like web forms.
All right, let's say web forms. Let's say it's the worst case scenario, because with MVC you can move some of the existing logic over. With web forms, you kind of have to rewrite the UI completely. You could probably reuse some of the business logic though, so you may be able to copy paste some business logic in there. I would say both Razor pages and Blazor are probably the easiest to. Blazor for the component model, I would say, is just going to be the easiest thing to just drop in and do some CRUD operations with, especially considering you're using just .NET code for that as well. So that's something, if you're just building, a simple CRUD task, you could probably do that in the matter of a few minutes. Yeah. Not talking about transitioning an entire application, but if you're just, saying, I want to try out building this one page that does CRUD, I already have an existing database that uses, say, like Entity Framework or has a web API, then Blazor is probably going to be the easiest. I'd say Razor Pages is probably the next easiest thing.
Yeah, and I'll kind of double down on what Veli had said. And Veli has probably seen a lot of like nightmares in terms of like business logic in your ASPX pages. Any type of business logic, especially if you consider the path forward with .NET MAUI or any other type of hybrid scenario where you have web and other things mixed up. Abstract them out, put them into a library of by themselves, like a .NET Standard library. Then you can, share and reuse across whichever platform that needs it. Dai Long was asking if you have web forms code right now, let's say a data grid. Do you have to rewrite the whole thing in Blazor, or are there like similarities maybe?
Sorry, what was that?
So if,
Yeah,
if you had, yeah, go ahead, Veli, go ahead.
I can chime in here. I think I replied to the poster. So web forms is not directly transferable to modern.NET of any flavor, Blazor or Razor. So if you have web forms applications that rely heavily on markup and controls, the typical data grid and other controls, you have to port them to a different technology. And porting means you have to re-implement them. Telerik controls is your friend here because of their extensive functionality and good feature coverage across the different flavors. So you are better off if your data grid is a Telerik UI for Ajax data grid and you are porting to MVC and Razor, let's say, and you're using Telerik UI for Razor. That's probably the best case scenario because you can use the equivalent component in the new flavor of .NET and then use the same features. If not, you typically start from scratch and then re-implement the same behavior in Razor or Blazor.
Yeah, well said. Maybe while we have you on, Veli, with your mic, Miguel was asking if or where, like I know you do a lot with deployments, like where can I run .NET 6 apps? What if it's not IIS? Can I run it in Apache or any other, hosting?
Yeah, excellent question. So you have a ton of options here. If you're deploying locally, your options are in addition to IIS, you could run it as a Windows service in the so-called self-hosted scenario, or you can run it as a Docker image on Windows on your workstation, right? And then in the cloud environment, particularly in Azure, you have even more choice. You can run it on app service, either on Linux or Windows environment, or you can run it in a Docker container the same way as locally, or the typical mainstream virtual machine setup where you spin up a virtual machine in Azure and deploy in IIS there. And finally, depending on your system architecture, you could have something very cutting edge. You can run it in a serverless environment in Azure where your front-end application or SPA like Blazor or Angular is hosted in what we call Azure Static Website Hosting or the Azure CDN. And then your backend could run potentially in an Azure function, which is a basic serverless container for your C# code.
Well said. And there is more work that's been done as we speak, with .NET 7, moving even further forward to make .NET apps more containerized. So, good times forward. Sai Kiran was asking, and I'm watching my time here. We are already over, but let's spend another, 2 minutes. There's a lot of Q&A, and I understand this is, near and dear to a lot of what people are doing. So we can do more on this. This was kind of focused more on the web side of things. I see a few questions about, MAUI and desktop and WinForms and WPF. That's all desktop. That's in my ballpark. Yes, you have a lot of options. There is no magic wand, but you can move things forward nicely. Ed, if you can hear me, is Blazor good for large-scale e-commerce sites like Amazon? And if you're building the next Amazon, good for you. But you have a need for an enterprise e-commerce app. Would you recommend Blazor at this point, like WebAssembly or server-side?
Yeah, Blazor's fine for large applications. I don't know if we have any that we're allowed to specifically mention here, but there are large scale Blazor applications that are in full production. So we're on the third large release of Blazor now.
Yeah.
So it's been
it is steady.
Yeah,
it is stable enough. Shah Chandan was chiming in to say, I don't need JavaScript anymore and no React and Angular, and I know this makes Ed happy, but if you have investments in JavaScript, you're fine. Keep them because for an enterprise, it's difficult to jump ship because like all of that can now be brought over to .NET MAUI if you want. But if you really want to do C#, this is kind of what like Veli was talking about, then yes, Blazor is your thing, but you don't have to. They can all coexist, and even if you have like MVC and Blazor, that can also coexist, is what what Ed's demo was showing. So you have a lot of choices. There is no right or wrong. It all depends on what you want to do, what your code base needs to do, and we want to be sensitive of our times here. I will point out one thing. Ed and me often code live on our Twitch channels, which is on Code It Live. So come and hang out with us. You can see us actually struggling through some bleeding edge projects at times, but that's part and parcel of being a developer these days. And we if Twitch is blocked, and we do record and put things up on YouTube. But from what I'm gathering with all of the questions and all of your excitement is we need to do more. So we are going to put together something where we have all of the content from me, Ed, and Veli in one spot, and we're going to put up the recordings so you have a spot to come and check out all the modernization strategies. And as .NET moves forward, as Telerik suites move forward, we are being very conscious that a lot of you are thinking about this. So we would like to put out more guidance on migration and modernization as things progress. Thank you, for spending like 2 hours of your day with us. I know that's precious, and we hope we give you some, food for thought, some things to consider. Veli and Ed, any parting thoughts?
Yeah, so from modernization, migration, architecture perspective, I think having choice is great, but also understanding the pros and cons for each of those options is also extremely important. And the good system architect is able to do this quick SWOT analysis and comparative analysis between the different technologies and pick the one that works for your case, right? As you said, Sam, rightly, there's no silver bullet here, no one size fits all type of a scenario, and each choice has its own pros and cons. Understanding those is extremely important for the right architecture and ultimately the success of any modernization project.
Yeah, very well said. I also like the fact that you mentioned like this is not a big bang surprise thing. It's like small bites while you keep delivering value to your business.
Yeah, I'll just echo what Veli said. Like there's no real bad choices as far as any of these frameworks go. There's bad implementations of things. You can write fantastic jQuery applications. You can write amazing web forms applications and Blazor and MVC and Razor Pages, all of those things. The implementation is where those things can go bad. So, do your homework, do your research, and choose the model that best fits your team, what their expertise is. If you have a team that is very handy with JavaScript and they love Angular, go with your MVC in the back end, the web API in the back end. Run some JavaScript on the front end, that's fine. Blazor is great if you have a very .NET focused team and you want to write a whole lot less JavaScript, then choose Blazor. None of those are bad options. They just fit different use cases.
Yeah, well said, well said. All right, people, we are going to call it a day. And one more time, we are all aware there's still a global pandemic. There are conflicts going on, so we genuinely hope you are well and your families are well taken care of. So let's all try being as productive as we can. And for anything you might have questions about migration modernization, feel free to reach out to us, Ed, me, and Veli, and we'll like to help out. And a big thank you to our folks who are in the back rooms helping us answer questions or keep this going. And hope you all have a great rest of your day, and take care. And we'll see you on the next webinar. All right, bye-bye.
Thank you.